In this video, we are going to discuss the last rule, which is called composite function. This is rule number 12. What are composite functions? Composite function is when one function is inside of another function. For example, if we look at fx equals to ln 2x minus 1, we can say that fx was formed by the composition of two other functions, the outside function and the inside function. Okay, to solve the derivative of composite function, let me introduce to you Tuppy method. Okay, if we have two composite functions, let's say we are given y equals to two composite function, and then to find derivative dy over dx, first we draw two circles, outer circle and inner circles. Then we pass these two circles with two other circles, and in between must multiplication operation. For the outer circle, we can refer the basic formula related with the outer function. And then for the inner function inside inner circle, we can refer the basic formula related for the inner function. Now, let me look at the example. Find the derivative of y equals to e the power of tangent x. From the given question, to find the derivative of y, we can draw two circles, outer circle and inner circle. And after that, we pass these two circles with two other circles. And in between must multiplication operation. For the outer circle, means to differentiate e the power of tangent x, we can refer basic formula from derivative of e the power of single x, which is e the power of single x also. Basic formula here means the variable is single x. The function is single x. So when we differentiate e the power of single x, it should be e the power of single x also. So when we differentiate e the power of tangent x, so it should be e the power of tangent x. Our x now is tangent x. And after that, for the inner circle, to differentiate tangent x, we can refer basic formula. So derivative of tangent x equals to sec squared x. So we can put here, derivative of tangent x equals to sec squared x. This is two composite function. And after that, we can simplify, so we can write dy over dx equals to sec squared x e the power of tangent x. Now how to differentiate three composite functions using Tuppy method. If we have y equals to three composite functions, to find dy over dx, first we draw three circles. The outer circle, and then the inner circle, and then the inner circle. Then we pair this circle with three other circles. And in between must multiplication operation. And then to differentiate the outer function, means inside the outer circle, we can refer from basic formula. And then to differentiate the inner circle, we can refer to the basic formula. And then to differentiate the inner circle with yellow color from here, we can refer the basic formula related to the function inside this yellow circle. Okay. Okay, now look at the example how to differentiate for three composite function. Okay. If we have y equals to ln sine bracket x squared, okay, to find the derivative of this function, okay, we need to draw three circles. The outer circle, and then the inner circle, and then followed by the inner circle. And after that, we pair these three circles with the other three circles. And then in between of these three circles must multiplication operation. And then to differentiate the inner function, the outer function, okay, means to differentiate ln function, we can refer basic formula from derivative of ln single x. Okay, when we differentiate ln single x, the formula is 1 over x. So means that when we differentiate ln sine x squared, it should be 1 over sine x squared. Okay, and after that, we need to differentiate sine x squared. So to differentiate sine x squared, we can refer from basic formula, okay, derivative of sine single x, okay, equals to cos x. So means that when we differentiate sine x squared, the answer should be cos x squared. Okay. And after that, we need to differentiate x squared. Okay. When we differentiate x squared, it should be 2x. Okay, we can put here. Okay. And after that, okay, we have 2x cos x squared over sine x squared. Okay. And we can simplify cos x squared over sine x squared. And the final answer is 2x cot x squared. Okay. Okay, now how to differentiate four composite function using Tuppy method. Okay. If we have y equals to four composite functions, when we want to find the derivative of y, which is dy over dx, first we draw four circles. The outer circle, inner circle, and then inner circle, and then the innermost. Okay. Then we pair all of these circles with the other four circles. Okay. And then in between must multiplication operation. Okay. For the outer circle, okay, to differentiate the function inside outer circle, we can refer the basic formula. Okay. And then for the function inside blue circle, we can refer from the basic formula related with the function in the blue circle. Okay. And to differentiate the function inside yellow circle, we refer the basic formula related to the function in yellow circle. And finally, to differentiate the innermost function inside the green circle, we refer the basic formula that relate to the function inside the green circle. Okay. Okay, now look at the example involving four composite function. Okay, how to differentiate four composite function using Tuppy method. Okay. Find the derivative of y equals to e the power of cos ln 3x squared. Okay. Okay, from the given question, okay, to find the derivative of y, okay, or dy over dx, first we draw four circles. The outer circles, and then followed by inner circles, and then the other inner circle and the innermost. Okay. Then we pair all of the circle with four other circles. Okay. And in between must multiplication operation. Okay. To differentiate the outer function inside the outer circle, we can refer the basic formula, okay, related to this function. So the outer function is e the power of something. Okay, means that we can refer from the basic formula e the power of single x. Okay. When we differentiate e the power of single x, it becomes e the power of e single x. So means that when we differentiate e the power of cos ln 3x squared, we have e the power of cos ln 3x squared back. Okay. And after that, we need to differentiate cos ln 3x squared. So the function now is, the outer function inside blue color now is cos. So we need to compare with derivative of cos single x, which is equals to negative sin x. So when we differentiate cos something, we have negative sin something. In this case, we have negative sin ln 3x squared. Okay. We assume our x now is ln 3x squared. And after that, we differentiate ln function. Okay. To differentiate ln function, we can refer from the basic formula. Derivative of ln x equals to 1 over x. Okay. So when we differentiate ln 3x squared, it should be 1 over 3x squared. Okay, we just assume our x now is 3x squared. Okay. And after that, we differentiate the innermost function, which is 3x squared. So when we differentiate 3x squared, we can use power rule. Okay. So we have 6x. Okay. Okay. From here, we can simplify 6 and 3. So we have 2. Okay. And we can simplify x and x squared. So we have x here. Okay. So after we simplify, the final answer is negative 2 over x sin ln 3x squared times e the power of cos ln 3x squared. So this is the final answer. Okay, got it? Okay, up to this point, we have discussed all the rules. So you can start doing exercises that involve derivative of any function in our syllabus. Okay. Coming up next, implicit differentiation. Thank you for watching. Stay tuned. Bye. Assalamualaikum.